Hey guys, welcome to a new tutorial. Today I want to show you how we can develop an interactive machine learning application with Streamlit. Streamlit is a free and open source framework to rapidly build machine learning web apps. I really like this framework because it's super easy to get started, even for beginners, and I think the UI looks beautiful. So let me show you the application that we're going to implement. So it's a simple machine learning app that lets you explore different classifier and different data sets. For example, here you can select the iris data set, the breast cancer data set, or the wine data set. And then you can select different classifier and also update the parameters for a classifier. And then here you get an overview of the data set and your classifier and then the accuracy. And you will also get a plot of the data set. And then you see that whenever we change something here, then this will be updated. So this is interactively. So that's what we're going to build. And now let's start. So in order to install Streamlit, we can simply do this with pip, and we say pip install Streamlit. So I already did this. And then we also need Scikit-learn and matplotlib. So we also have to say pip install Scikit-learn and also pip install matplotlib. So as a bonus, you will also learn here how to use the Scikit-learn framework and implement different machine learning classifier pipelines. So let's do this. So first, I recommend, in order to explore Streamlit, simply say Streamlit hello after installation. And this will fire up the basic example app. So now if we go to a localhost where it is hosted, then we will see we have different examples. For example, I can choose the plotting demo. And then we see this demo, and when it's loaded, we will also see the code. So then you can have a look at the code and explore this. So I recommend that you check out these 4 examples. And now let me close this again. So now let's stop this server here and let's start implementing our own app. So in order to get started, we have to import Streamlit. So we say import Streamlit as st. And then, for example, we can set a title by saying st title and then give it the title. So let's say Streamlit example. And now we can save this. And now in order to run our own script, we have to say Streamlit run and then the name of our file. So in this case, it's main.py. And now when we hit enter, we will see that our app is hosted on localhost 8502. So let's open this. And then we will see here we have our app up and running. So this is working. And by the way, we can also activate hot reloading. So we can click here and then on settings and then run on save. So this will update our application whenever we do a change here and save it. So let's continue. So after we set a title, we can also, for example, simply write some text. So we can say st.write. And here what we can use markdown language. So we can, for example, use a h1 tag and use a heading. So we say explore different classifier. And now when we save this and go back, then we see we already have this here. So this is a h1 heading. And we can also write normal text, of course. So we say which one is the best, and then save it and go back, and then we see the text appears here. So now we can see how we add text. And now we also can add different widgets. For example, let's add a select box. So we can say Streamlit and then dot select box. And then here first we can give it a title. So we say select data set. And then here we give it the different options as a tuple. So here, for example, we want to have the iris data set. We want to have the breast cancer data set. And we also want to have the wine data set. So these are all popular data sets for machine learning beginners. And now if we go back to our Streamlit app, we see that we already have this selection box where we can select iris, breast cancer, or wine. And then what we can also do is we can assign this to a variable. So we say dataset name equals this. And then whenever we choose a dataset in the select box, then this will be assigned to this variable. For example, we can say Streamlit write and then the dataset name. And then we see that this will be updated. So now if I choose wine dataset, we will see we have the text here. So whenever we do a change with one of the widgets, the whole script will run again, and then that's why we get the update here. And now if you ask yourself, isn't this super slow if the whole script is running again? And for that I can tell you that Streamlit has some intelligent ways to cache these things. But I will not go into this in this tutorial, but you should know that you can cache some things that you already computed, and then the whole script doesn't have to run again. But for now, this is fine. So whenever we do a change, then this will be updated. And we can also easily move this to a sidebar. So for this, we can say here Streamlit dot sidebar and then dot our select box. And now we see we already automatically got a sidebar. So isn't this beautiful? And so now we get our dataset select box. So now let's move on. So now what we also want to have, we want to have different classifiers. So let's create a select box for this too. So let's say classifier name equals, and then let me copy and paste this. So this is also a select box at the sidebar. And here we say select classifier. And for this example, I want to use 3 popular machine learning classifiers. So this is the k-nearest neighbor algorithm, the SVM algorithm, support vector machines, and also let's use random forest. So I will not explain them in detail, but if you want to learn more about these, then I can recommend that I have a whole playlist about machine learning algorithms from scratch. So I will put the link in the description and you can check this out. So now we get the different classifiers. So let's have a quick look. So here we have KNN, SVM, and random forest. And now let's load the data set. So for this, we are going to define a function. So let's call this get data set, and this will get the data set name. And based on this data set name, it will load different classifier. So for this, we are going to use the scikit-learn library. So you have to install this, as I said in the beginning. And then we can say from scikit-learn, we import data sets because we have some of them already included in the library. And now down here in our function, we will check if dataset name equals, and then we compare them with our names here. So if this is Iris, then our data set, or let's simply call this data, equals datasets dot, and then we can call load Iris. So this is already included in scikit-learn. And then we say elif dataset name equals, and we also have breast cancer. Then our data equals datasets dot get, no, it's called load breast cancer. And otherwise we say our data equals datasets. So this is the last option, and here we say load wine. And then we will split this into x and y. So we can say x equals data dot data and y equals data dot target. And then we simply return x and y. So now we load the different data sets. So let's call this function here. So we say x and y equals gets dataset, and then we put in the dataset name. So as I said, we assigned this to a variable here. So we can use this here. And now let's simply write some information so that we can see that this worked. So we say streamlit.write, and then let's say we want to have the shape of the data set, and this is here we can use x.shape. And we also, let's say we want to get the number of different classes in our data set. So for this we say streamlit.write and then number of classes. And then we say we want to get the length of NumPy unique and then y. So this will put in all the unique values. For example, if we have classes 1, 2, and another 2, then it will only output 1 and 2. And then the length of this is 2. So let's save this. And yeah, if we see, we get an error here right away, which is helpful. Name NP is not defined. And for this, of course, we have to import NumPy. So we say import NumPy as NP. And this should be installed when you install scikit-learn, by the way. Otherwise, you can also install it with pip. So now if we reload this, I think now I have to hit enter. So now we see that it's working. So now let's choose, for example, the breast cancer data set. And then we see the shape got updated and the number of classes. So it seems to work. So now let's continue. So the next thing we want to do is to get different parameters that we can modify for each of the classifiers. So what we do down here is let's create another function. Let's say define, and let's call this add parameter UI, and this gets one parameter. So this will be the CLF name, the classifier name. So based on this, we will output different parameters, and we will also put them in the UI. So let's create an empty dictionary here, and then let's check our parameter or our classifier name here. So if CLF name equals, and the first thing is the KNN. So here we say our K equals, and then we add this to the sidebar. So we say streamlit.sidebar dot. And then we use another widget, and this is the slider widget. So we give it a name that is k, and then we will give it a start and a stop value. So for example, as a k, let's do from 1 to 15. And we could also give this a type, so if it is integer or float, but Streamlit can also figure this out on its own if the data type is clear. So I will leave the data type out here. And then we will put this in the dictionary. So we say params, and then as a key, we say the key is k, and then we put in the k. So let's return the params down here, and then let's also call this parameter UI with the classifier name, so that we got up here. So classifier name. And now let's see if this works. So if we reload this, so I think sometimes we have to reload this manually. But yeah, so now we see we have our slider widget, which ranges from 1 to 5. And then we also see sometimes when we update the value here, we quickly see that it's running. So it's also running our script again. So this works. So for the K and N, it's very easy. We only have the K, so the number of nearest neighbors that we want to have a look at right now. And then let's also do this for the other two classifiers. So we say elif CLF name equals SVM, and then we do the C parameter. So I recommend that you check out the official documentation. So let's Google SVM Scikit-learn, and then you can see that one of the most important parameters is the C value. So let's do this. So let's do the same as we are doing here. But now we call this C, and we create a slider for this. And in this case, we want to have the range from 0.01 up until 10.0. So now it figures that this, or it can figure out that this is a float value. And then we also do this, or put this into our parameter dictionary. So params C equals C. And so I'm only going to use this one. I can recommend that you check out the official documentation and do this on your own for the other parameters, but for now this should be fine. And now, as a last classifier, we do it for the random forest parameter, random forest classifier. So one important parameter here is the maximum depth for our trees. So we say max depth equals, and then we again use a slider widget. So let's call this max depth, and this should range, for example, let's say from 2 to 15. So minimum 2 trees and maximum 15. Sorry, this is not the number of trees, but the number of depth for each tree. But we also can configure the number of trees. So for this, we say number of estimators equals, and then the same as here, again, a slider widget, which we call the number of estimators. And then let's say this should range from 1 to 100. Again, I recommend that you check out the documentation. So if we Google sklearn random forest, then you will see all the different parameters, and for now we only use this one and this one. And then of course we have to put this into our dictionary. So we say params, and as a key we call this the same as we called it the variable. So max depth equals max depth, and params, and then the number of estimators equals n estimators. And then we return the dictionary at the end, and then we should have those parameters. So as a last thing that we must set up is to create the classifier. So now let's first let's save this and let's have a look at our app if this is working. So when we have the k and n, we have the k parameter from 1 to 15. When we have SVM, we have the c parameter from 0.01 up until 10. So this is a float value here. And then for random forest, we should get 2 sliders. So yes, so one is the max depth and the other one is the number of estimators. So this works. And let's continue. So now we want to get or create the actual classifier. So let's create another function, get classifier, and then again based on the classifier name and also based on the params. So here this will return the params. So we say params equals, and then we call the function. And down here, we do the same as here. So the same if statement and elif statement. And here we want to create the actual classifier. And for this, we have to import them from scikit-learn. So we do this up here. So we say from scikit-learn, and then it's called neighbors, and then we want to import k neighbors classifier. I'm wondering why the autocomplete is not coming up, but never mind. So we also want to have scikit-learn.svm import, and this is called svc, so support vector classifier. And we also want to have the random forest, and we get this from scikit-learn dot ensemble. We want to import, it's called random forest classifier. I hope that I don't have a typo now, but let's try it out. So down here, we want to create them. So for the k and n, we simply say our clf equals, and then k neighbors classifier, and as a parameter, it gets n underscore neighbors equals, and then here we say params with the key k. So this is our k and n. And then for the svm, we do it with the svc, and here as a parameter c, we use the params with key c. And as a last thing, we want to set up a random forest classifier. So here we say clf equals, and then random forest classifier. And this will get the number of estimators equals, and then the params with the key n estimators. And let's do also the max depth equals params with the key max depth. And we also put in a random state so we can reproduce our results, because as the name says, this is randomized. So let's put in one random state, 1, 2, 3, 4, whatever you want. And then we have our random forest classifier. So let's simply return this. So then we call the function here. So we say our CLF equals get classifier. And here we put in the classifier name and the params. So let's see if this is working. So let's reload this. And we don't have an error here, which is good. So yeah, here we do have an error. Let's try out this one. We also do have an error here. So let's have a look at this one first. So we don't have C defined in line 57. Params C equals C. So yeah, we don't want to update this here. So now let's save this and let's run this again. Now if we select SVM, then this is working. And if we select random forest, we still get an error in line. There are multiple identical ST slider widgets with the same generated key. So, yes, this is because we don't want to have the sliders again here. We already create them up here. So here we simply want to create our classifier. So again, let's save this and let's run this again. So now if we select random forest, then we see this is not producing an error. So this looks good. So now we can continue. So now we can finally do a classification. So let's say classification. And for this, we want to import one more from scikit-learn. So we say from scikit-learn dot model selection, we import, and this is called train test split. And this will split our data into training data and test data. So now let's do this. So down here we call this. So we say x train and x test, and then y train and y test equals, and then train test split. And then here we put in x and y. So we already got this here. So we want to split this data, and we can define the ratio by saying the test size should be 0.2. So 20% of the data is used for testing and the other one is used for training. And we can also give this a random state to reproduce our algorithm. So let's say this is 1, 2, 3, 4. And then to train our classifier, we simply have to call clf.fit and then x train and y train. So the API is the same for all the classifiers in the scikit-learn library. So this is pretty nice. And then after fitting, we want to call the predict method. So we say y predict equals clf.predict. And then here we use the x test data. And then we have the predictions. And now let's create the accuracy. So for this, we also want to import this measure. So we say from sklearn.metrics, we import, and this is called accuracy score. And then down here, we can use this. So let's compute this. So let's say accuracy equals accuracy score. And this will need the actual labels. So this is called y test. And then the predicted labels. So y predict. And then let's write this to our app. So let's say streamlit.write. And then let's use an f string here. For this, you need Python 3.7 or 3.8. And then let's simply first write our classifier name. So let's say classifier equals, and then in curly braces, we can use a variable here. So we use the classifier name. And let's also write the accuracy. So another f string, and then we say accuracy equals, and then in curly braces we call the acc variable, so the accuracy. And now if we load this again, then this should be here. So now we can explore the different classifiers. So for example, here we see with k equals 7, we have a accuracy of 0.96. And for example, with 10 k nearest neighbors, we have accuracy is 1.0, so perfect. And yeah, the iris data set is pretty easy, so we should get a perfect or almost perfect accuracy with the different classifiers, and that we can see here. And so let's choose the breast cancer data set. So this is a little bit more complex. And yeah, so now you can play around and see which parameters are the best. And now as a last thing, I also want to show you how we can plot the data set. So down here, let's say plot as a comment, and for this, we use a little trick because our data set can have more than 2 dimensions, but we can only see this in a 2D plot. So for this, we say from sklearn.decomposition, we import PCA. So this is the principal component analysis algorithm. And I already also show this in my machine learning from scratch tutorials. So this basically is a feature reduction method that will transform or project our features to a lower dimensional space so that we can have it in 2D. So here, let's call this. So let's say PCA equals PCA. And then we have to specify the number of dimensions that we want to keep. So we say 2 for 2D. And then we can get the projected data by saying x projected equals PCA.fit transform. So we can do this in one operation. And here we put in the whole data, x, and that's it. So note that we don't need the y here. So this is a unsupervised technique which doesn't need the labels. So this is very important to remember for PCA. And now let's plot our data. So we also have to import matplotlib, of course. So let's say import matplotlib.pyplot as plt. And then we can use this. So we simply want to create a 2D plot. So let's get the first axis by saying x1 equals x projected, and then we use slicing. So we want all the samples, but only the dimension 0, and x2 equals the same in dimension 1. Then we create a figure, so figure equals plt.figure, and then we say plt.scatter, and here we want to scatter x1 and x2, and then we also want to plot this in different colors based on the labels. So we say C equals Y. And we also can give it a alpha, let's say 0.8, to make it a little bit transparent. And then let's also define a color map equals vRedis. So this is a built-in color map in Matplotlib. That looks pretty nice, I think. Then let's also give this a label. So let's say plt.xLabel. xLabel equals, and then let's call this principal component 1. And let's copy and paste this and do this for the Y label. So this is the principal component 2. And then let's also plot a color bar, so plt color bar. And now instead of calling plt show, so this is what you would do with normal code, we do st.pyplot. So this is also built in our Streamlit application framework. And then if we reload this, we should see the plot here. So we see it's working, and we have the iris dataset with, for example, 4 dimensions transformed into only 2 and plotted here. And now if we select a different one, we see that also the plot is updated, and let's do it for the wine dataset as well. And yeah, so we see this is working, and now we have a nice little interactive machine learning web app. And yeah, I hope you enjoyed this. And now if you want to have any assignment which you can improve on your own, so then I can give you some more tasks. So for example, one thing that you can do is you can add more parameters. So as I showed you in the scikit-learn library, there are more parameters available for most of the classifiers, so try them out as well. Then you can also, of course, add more or add other classifier. And as a last thing, I also recommend to play around with feature scaling. So add feature scaling. You also have a lot of methods available in scikit-learn framework. So this is what I would recommend that you can try out on your own. And that's all I wanted to show you for today. I hope you enjoyed this tutorial, and if you liked this, then please subscribe to the channel, and see you next time. Bye.